Hello and welcome to Math 200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will do a homework problem from section 6.5. It says that the overhead reach distances of adult females are normally distributed with a mean of 202.5 centimeters and a standard deviation of 8.6 centimeters. They want us to find the probability that an individual distance is greater than 215 centimeters, and then they want us to find the probability that the mean for 20 randomly selected distances is greater than 200.3 centimeters. Let's focus on those two problems first. And I have some information here about the mean and standard deviation. The formula that we will use is called the normal distribution, NORM DIST, and it requires an x value, the mean and standard deviation, and then it's asking if it's cumulative. Since we're looking for the area, our cumulative is going to be true, and we have to remember that the normal distribution looks for the cumulative distribution from the left side. So having something that's greater than 215 is referring to the area on the right side. So area to the left is what we will compute, and then we will shift that to the area to the right. Because this function, normal distribution function, will give us the probability that we're looking at something that's less than 215. So let's find this area to the left. That's NORM DIST, open parentheses, and we'll start off with 215. And now we want the mean. The mean is 202.5. We can type 202.5, or you can just click on 202.5, comma, the standard deviation is 8.6. Again, you can type 8.6 or just click on that cell, and then we'll say cumulative is true, and we're going to get a value of 0.926955, etc. To find the area on the right, we're going to say equals and then 1 minus that value that we just found, and that is going to be 0.073044. So let's take that first answer, 0.07304, and type that. And we want to round off to 4 decimal places, and since 4 is less than 5, we'll keep it at 0.0730. Alright, that looks good. The next probability for 20 people. Now this is a little bit tricky. We will still get the same process where we find the area to the left and subtract it from 1, which, by the way, you can do in one command, but we will use this step by step. Now the tricky part about this is that if we're looking at 20 individuals, we're going to get a new standard deviation. So our standard deviation will not be exactly the same. I'm going to just copy this over and paste it on, but our standard deviation for 20 people will be a little bit different, and our standard deviation for 20 people will be the old standard deviation, but we're going to divide by the square root of however many number of people we have. So that would be 8.6 divided by the square root of 20. and that is going to be the new standard deviation that we will consider. So back to this problem, we'll say equals norm dist, open parentheses. This area now is not quite the same as 215. I think it's 200.3. And then our mean is 202.5 again. And this time remember that our standard deviation is not 8.6 anymore. It's actually this other one. It's 1.923. And then we'll say true and hit enter. Now we want the complement of this, which is going to be 1 minus this number. And then we get 0.87369. And if we're rounding off to 4 decimal places, that would be 0.8737. Let's type that in, 0.8737, and that looks good. Final question, choose one of the correct answers. The normal distribution can be used because the original population has normally distributed. The normal distribution can be used because the mean is large. I don't think that's a good reason. The normal distribution can be used because the probability is less than 0.5. That's not a good reason either. The normal distribution can be used because the finite population correction factor is small. I think this first one talks about this normally distributed, so that would be a fine time to use a normal distribution. Let's check our answer, and that looks good. I hope that helps.